In this exercise, we are asked to find equations of the tangent line to the graph of f of x equal to x plus 1 over x minus 1 that are parallel to the line 2y plus x equal to 6. Then graph the function and the tangent lines. The first thing is to find the slope of our line 2y plus x equal to 6, because that slope will also be the slope of our tangent lines. So I'm going to rewrite 2y plus x equal to 6 in the form y equal to mx plus c. So doing a bit of math here, I'm going to have 2y equal to 6 minus x dividing by 2 on both sides. I get y equal to negative 1 half x plus 3. Therefore, the slope of our tangent lines is simply going to be negative 1 over 2. So I'm going to find the derivative now of our function f of x by using the quotient rule. So f prime of x is simply going to be x minus 1 squared in the denominator, and I will have x minus 1 times the derivative of x plus 1, which is 1, minus x plus 1 times the derivative of x minus 1, which is also just 1. Doing a bit of simplifying here. In the denominator, I have x minus 1 square. In the top, I will have x minus 1 minus x minus 1. Notice the x will cancel out. We are left with negative 2 over x minus 1 square. And that is the derivative of our function f of x. Now we'll set that derivative equal to the slope of our tangent lines, negative 1 over 2. And we'll solve for x by using cross multiplication. And when you use cross multiplication, you get negative 4 equal to negative x minus 1 squared. The negative cancel out. You're left with x minus 1 squared equal to 4. Solving for x now, we have x minus 1 equal to the square root of 4, x minus 1 equal to plus or minus 2. So we have two values here for x. X is either going to be 2 plus 1, or x equal to 3, or x is going to be negative 2 plus 1, or x is going to be equal to negative 1. So we have two values for x, either 3 or negative 1. We'll take these values now and substitute back in our functions to get the corresponding y values. So doing that work here, f of 3 is going to be equal to 3 plus 1, 3 minus 1. F of 3 is going to be equal to 4 over 2, or f of 3 is going to be equal to 2. So there goes the first coordinate point, 3, 2. I do the same work for x equal to negative 1, substituting back into the function f of x. So f of negative 1, we have negative 1 plus 1 over negative 1 minus 1. So f of negative 1 is simply 0. So the second coordinate point is going to be negative 1, 0. So for these 2 points that we found, we're going to use the point slope formula and actually find the equation of our tangent lines. So using the point slope formula here, we have all the information we need. The very first equation of our tangent line is going to be y minus 2 equal to negative 1 half x minus 3. We're doing a bit of work here, adding 2 on both sides, negative 1 half x minus 3 plus 2. Doing a bit of simplification here in this step, we have negative 1 half x plus 3 over 2 plus 2, or y equal to negative 1 half x plus 7 over 2. So this is going to be the equation of our first tangent line. Going to the second case where the points are negative 1, 0, we're finding the equation of the second tangent line here. We have y minus 0 equal to negative 1 half x plus 1. So y equal to negative 1 half x plus 1. So this is going to be the equation of our second tangent line. Now we have all the information we need. We need to go ahead and graph now. So to graph the function of f of x, x plus 1 over x minus 1, we need to find y-intercept. The y-intercept occurs when x is set to be 0. All right. So you set x as 0. F of 0 is simply going to be negative 1. Okay. So our y-intercept is 0, negative 1. X-intercept occurs when you set the entire function equal to 0, because we're talking about the roots of your function, right? So x plus 1 over x minus 1 has to be 0. And for that to happen, the numerator has got to be 0. So we set x plus 1 equal to 0. Subtract 1 on both sides. We get x is equal to negative 1. Okay, so our x-intercept is going to be negative 1, 0. So now that we have those two, we move to finding the stationary points of the function, or do we have any? Stationary points of a function happen when the gradient reaches 0. When you look at the derivative of your function f of x, you notice that the numerator is a constant negative 2. So this gradient will never reach 0. So there are no stationary points in this case. No stationary points. Now let's move on to looking at vertical asymptotes. Vertical asymptote will occur when this function f of x becomes undefined. For it to be undefined, it means that x minus 1 has to be 0. Okay. Or if you set x minus 1 equal to 0, x is equal to 1, this is my vertical asymptote. Horizontal asymptote. For horizontal asymptote to occur, we need to look at the behavior of x as x tends to infinity. So as x goes to negative infinity, notice that your y is also going to go to 1, right? If your x goes to negative infinity here, your y is going to go to 1. And if you look at x going to positive infinity, you're going to notice that your y also is going to 1. So there goes your horizontal asymptote. Y equal to 1 is your horizontal asymptote. All right, so we have all the information that we need to graph this hyperbolic function. I'm going to start by graphing the tangent lines, and then I will move to graphing the function f of x. So the very first equation I'm going to graph is the negative 1/2 x plus 7 over 2. Using the points given to me here, 3, 2, all right, and using my rise over the run or slope, I'm going to get a couple of points here, okay, just so I can get my line here. So there goes the first tangent line. There goes y1. Now let's move to graphing y2. All right, I'm going to graph y2 by putting in the first point, negative 1 over 2. Negative 1 comma 0. Negative 1, 0 is right here. And using the rise over the run, getting a couple of points here. Same thing. So there goes our tangent line 2. y2. And finally, we get f of x. So looking at f of x, we have all the information we need to graph f of x. So let's start with the vertical and horizontal asymptotes. Okay, there goes the vertical asymptote here. This is x equal to 1, and horizontal asymptote, this is y equal to 1. Let's get the y and x-intercept. So we have 0, negative 1. And then we have negative 1, 0. So we graph f of x. All right. Let's graph f of x. There we go. We have our hyperbolic function on the graph and our tangent line as well with the slope negative 1 over 2. And we are done.